So far in this module, we've covered solute and solvent and mole fractions. In this video, I'm going to be going over colligative molality. Now, using these three videos, we'll be able to build all the tools we need to answer the colligative property questions in the following two videos. So if we were to see something written like this, lowercase m(c), this would be equal to colligative molality. So, and note that this is a lowercase m. So what is this equal to? So MC is equal to m, and this is little m, times I. So what do all these terms mean? So this colligative molality is going to be equal to m, which is, first of all, your molality. Now, note, this is not the same thing as molarity. Molarity is denoted with a capital M, and that is the moles per liter of a solution. Molarity is equal to moles of solute over kilograms of solvent. So again, the colligative molality is equal to the molality times I, and molality is moles of solute over kilograms of solvent. It becomes the colligative molality when we then multiply by this I factor. So what is this I factor? This is called the Van't Hoff I factor. And it basically tells us how many things our solute that we are dissolving in the solvent is going to break up into when we put it into a solution. So let's do some practice with this. So if we were to have a beaker of water, we were going to dissolve sodium chloride into this water. This would break up into Na plus and Cl minus. So the I factor is 2 because this broke up into two things when we put it into water. If we were to take something like MgCl2, this would break up into Mg2 plus and 2Cl minus. Remember, you have to balance the equation. So this is MgCl2 breaks up into Mg2 plus 2Cl minus. That would be the balanced equation. So this actually, for the I factor, would be 3. You get 1 magnesium and 2 chlorines for every time you dissolve magnesium chloride into solution. So the I factor is pretty straightforward. It's just how many things that you dissolve. So lastly, if you were to dissolve a non-ionic compound like CH4 that is held together by covalent bonds, we know covalent bonds are the sharing of electrons. They do not dissolve in water at all. This CH4 will stay completely intact. The I factor for this is 1. It does not split up into 1 carbon and 4 hydrogens. It stays 1 molecule. So that is the I factor. So just taking a look again at what colligative molality is, it is the molality of our solution, which is moles of solute over kilograms of solvent, times the I factor, which is how many things that something is going to break up into when we put it into water. So if we were to look at an example problem, if we were to have beaker of water, and we are to have 1,000 grams of H2O, and we were to dissolve 3 moles of NaCl into this water, what would the colligative molality be? So MC would be equal to the molality, which is the moles of solute, so 3 moles of solute over the kilograms of solvent. There is 1,000 grams of 1 kilogram, so 1 kilogram of solvent times the I factor. Now we saw from up here that NaCl breaks up into 2 things when we dissolve it into water. So you just multiply this by 2. 3 times 2 is 6. So the colligative molality for this solution would be 6. So like I said, knowing solute and solvent, knowing mole fractions, and now knowing what colligative molality means is going to really help us solve colligative property problems coming up in the next couple of videos.